Today, inshallah, we are going to start Unit 3, Model 1, Lesson 3. It's called the Thermal Energy Transfer. At first, our objectives. By the end of our session, we have to identify heat transfer and explain how we reach the thermal equilibrium and also compare between the three ways heat transfers. And here we have keyword. The first one is called electromagnetic waves. What is the meaning by electromagnetic waves? Waves that travel through empty space and through matter, like light energy. Light energy can transfer through air, because air is matter, and also it can transfer by space, like light energy of the sun. Okay, can reach our planet by space or through space. And the second concept, we have to know what is the meaning by equilibrium. Equilibrium, it's a state in which two things are balanced, maybe equal each other. The third one, it's called the magma. What is the meaning by magma? Magma, it's a molten rock inside Earth. Okay. The fourth one, it's called method. Method, it's a plain way of doing something. It's a plain way of doing something. And here we have a system. What is the meaning by system? System, it's a group of related parts that move or work together. It's a group of related parts that move or work together. And the last one, it's called the transfer. What is the meaning by transfer? Transfer means to move something from one place to another, which means make movement. Can you tell me again what is the meaning by electromagnetic waves?
Waves that travel through empty space and through matter.
Like what?
Like light.
Yes, bravo. And what is the meaning by equilibrium?
A state in which two things are balanced.
Yes. What is the meaning by magma?
Molten rock inside Earth.
Yes. What is the meaning by method?
A planned way of doing something.
Yes, right. What is the meaning by system?
A group of related parts that move or work together.
Yes. What is the meaning by transfer?
To move something from one place to another.
Yes, thank you. Here, at first, we have to know and learn about heat transfer. The thermal energy exchange between two objects of different temperatures. If we have two objects with different temperatures, which means the first one maybe have the more temperature or more heat energy, and the second one have less heat energy or less temperature. So energy moves in a predictable pattern from warmer one or warmer sides to cooler sides or cooler one until all sides or all sides have reached the same temperature. By this way, they reach or they make equilibrium. Okay, do you understand?
Yes.
Yes. Okay. Direction of thermal energy transfer. Thermal energy always move from a higher temperature to a lower temperature object. So thermal energy again always moves from a higher temperature object to a lower temperature object. Heat, it is the amount of thermal energy moving from region of higher temperature to a region of lower temperature. Okay? So if I ask you what is the meaning by heat, you can tell me it is the amount of thermal energy moving from a region or a part of higher temperature to a region of lower temperature. Okay, can you tell me what is the meaning by heat?
Heat is the amount of thermal energy moving from a region of higher temperature to a region of lower temperature.
Thank you. Okay. We have a concept, it's called conduction. So, conduction, what is the meaning by conduction? It's a transfer of thermal energy that occurs in solids or liquids and gases when two substances of different temperatures touch. So again, what is the meaning by conduction? It is a transfer of thermal energy or heat energy that occurs in solid objects like iron, or liquids like water, and gases. Okay, when two substances of different temperatures touch. Okay, have you ever burned your fingers on a hot pan while cooking? Your fingers, what will happen? Your finger burned as thermal energy moved from the hot pan, which means the higher temperature object, to your cooler skin, the lower temperature object, your skin. Okay? You understand?
Yes.
Okay. Conduction, transfer of thermal energy between matter by the collisions of particles. When particles at different temperatures collide, which means they crash with each other, particles with higher kinetic energy transfer energy to particles with lower kinetic energy, like this. They pushing each other. Motion of both particles will change. Motion of both particles will change because the particles which have the higher kinetic energy will lose some of this energy, and the particles with lower kinetic energy will gain some of this energy. Okay?
Okay.
When one energy changes, there is always another energy changing at the same time. When one energy changes, there is always another energy changing at the same time. For example, if particle transfers, which means lose kinetic energy, will move slower because it loses this kinetic energy. If a particle gains kinetic energy, it will move faster. Okay, which means this energy, this speed will increase, or its speed will increase. And here we have a new concept, it's called radiation. Radiation, when sunlight feels warm on the skin, sunlight feels warm on the skin, this warmth is the result of radiation. Okay, so again, when sunlight reach our skin, it causes warmth. Okay, this warmth is a result of radiation of the sun. You understand?
Yes.
Okay, radiation, what is the meaning by radiation? Radiation, it is the transfer of thermal energy from one material or one matter to another by electromagnetic waves. Radiation transfers thermal energy through matter or space, like light energy or heat energy. Light energy or heat energy can transfer on space or through matter, where no matter exists. Space means where no matter exists. Okay. After that, we have radiation differs from conductions. What is the difference between radiation and conduction? Because radiations can happen through matter or material, but conduction can only happen through material. It cannot happen without material. Because it can occur between objects that are not touching. Because radiation can happen between objects that are not touching. Electromagnetic waves, like sunlight, carry thermal energy between objects. Electromagnetic waves, like sunlight, carry thermal energy between objects. You understand?
Yes.
Okay. The third concept is called convection. Okay. Convection. What is the meaning by convection? It's a transfer of thermal energy by the movement of particles from one part of material to another, like in liquids. Okay. How else does thermal energy transfer in liquids and gases? How thermal energy or heat energy transfer in liquids and gases? By convection. So thermal energy can transfer in the third way. It's called convection. So again, thermal energy can transfer in a third way called convection. But in what? In liquids, in gases. So convection, it's the transfer of thermal energy by the movement of particles of liquids or particles of gases from one part of a material to another. Okay, convection explains why hot air rises and cooler air sinks. Again, convection explains to us why hot air rises and cooler air sinks or go down. So, as the toaster warms the air in the toaster, the air rises and moves upward into the room. And convection also occurs in liquids and gases. Convection doesn't occur in solids. Convection doesn't occur in solids. Okay? But can you tell me what happened in solids? How heat energy can transfer in solids? By conduction, not convection. So convection, it is the way by which the heat can transfer through liquids and gases. But conduction, it is the way by which the heat can transfer through solids. Because the particles in solids cannot flow. Because particles in solids cannot flow, they cannot leave their places. They can make only vibration in their positions. They cannot leave their places. You understand?
Yes.
Yes, because solid particles have lower kinetic energy, but liquid and gases have more kinetic energy, so they can move and leave their places and go to another position. Okay, after that we have here a figure. This figure tell us about this layer, this green layer. It's called the crust. It's called the crust. And under crust there is a mantle. Mantle is the second layer of Earth. So the first layer on Earth or of Earth is called the crust. And the second one, it's called the mantle. Mantle, it's maybe like molten rocks. And the third layer, it's called core. Okay, so the Earth, it consists of three layers. The first one, it's called the crust. The second one, it's called the mantle. And the third one, it's called core. Magma, it's a noun. It's a molten rocks inside Earth. It's a molten rocks inside Earth. Earth science connection. Convection plays an important role in the cycling of materials in Earth systems. So again, convection plays an important role in the cycling of materials in the Earth systems. As convection currents circulate water in Earth's oceans and other bodies of water. Again, as convection currents circulate water in Earth's ocean and other bodies of water. Convection also thermal energy also moves air on Earth's surface, and the magma in Earth's interior is shown in the figure on the right, like this, because magma can transfer as a circle. Do you understand?
Yes.
Okay. So can you tell me what is the importance of convection on Earth? An Earth system. Can you tell me?
Convection plays an important role in the cycling materials and Earth system.
Yes. Material, this material can be iron, copper, and all metals, but all of this are in molten state. Okay. And also, we say that convection currents circulate water in Earth, which means they can cause the water waves in Earth's oceans and other bodies of water. And also, convection of thermal energy also move air on Earth's surface because the hot air can move up and the cold air can move down. And also magma in Earth's interior as in shown figure on the right like this, in these directions. After that, here we have a question. Which lab equipment did Valinda omit from her materials list that will ensure her personal safety as she performs her experiments? Can you answer?
Yes.
Okay, but we have to enlarge this page. Can you look at your student book, page 53?
Okay.
Okay. He says that Valinda wants to verify that thermal energy moves from warmer substances to cooler substances. Again, Valinda wants to verify that thermal energy moves from warmer substances to cooler substances until all the substances attain the same temperature, which means that they reach the equilibrium state. She writes her experimental plan after forming her hypothesis about what will happen to the temperature at different locations. Throughout the system, she develops a materials list and procedure for her investigation. This material, the first one, hot plate. Hot plate is the first material which she brings. The second one, 500 milliliter beaker. The third one is called thermometers. The fourth one, timer. Okay, and piece of ice and water. Okay. Okay.
Yes.
Okay. And now the procedure, the first step, we have to place water and ice in the beaker. We have to place water and ice in the beaker. The second step, take the temperature of the water in the bottom of the beaker. and the center of the beaker and the top of the beaker. Again, take the temperature of the water and the bottom of the beaker and the center of the beaker, and finally the top of the beaker. The step number 3, start the stopwatch and record the temperature. Start the stopwatch and record the temperature. Number 4, place the beaker with water and ice on the hot plate. Place the beaker with water and ice on the hot place. Turn the hot plate to medium heat. Turn the hot plate to medium heat. The 5-1, every 2 minutes, record the time and temperature until the water boils. And here we have communication. In your science notebook, create a graph with the data. Write a report that includes the hypothesis, whether the hypothesis is supported, and conclusion statement about the thermal energy movement. Okay? Okay, Maytha, can you hear me?
Yes.
Okay, so here we have a question. Which lab equipment did Valinda omit from her materials list that will ensure her personal safety and as she performs her experiments? Can you tell me?
Goggles, apron, heat-resistant gloves.
Yes, goggles, apron, heat resistance, gloves, heat resistant gloves. Okay, thank you. The third question, identify the independent and dependent variables of the experiment.
Independent time and dependent temperature.
Yes, because temperature depends on time, okay? So your answer is true. Goggles, apron, heat-resistant gloves. And also, this question is true. Independent time, independent temperature. Okay, thank you. Our session is finished.